So the complete solution x, it is the addition of complementary function plus particular integral. Okay. So first we will try to find out the complementary function. So we have the d operator equation like this, which is a d square plus c upon m d plus k upon m into x, which is equal to f0 upon m sine omega t. Okay. So for the complementary function, which is x complementary, so you should assume this term, or we should equate this complete term left hand side with 0. So we will get the equation d square c upon md plus k upon m, and this is equal to 0. Okay. Now the roots of this equation, so we have already derived this in the damp vibration. Okay. So I will directly give the root of this equation. So the d1 and d2, so these roots are this is minus zeta omega n plus or minus the square root zeta square omega n minus omega n square. Sorry, zeta square omega n square. So this is equal to minus zeta plus or minus square root zeta square minus 1 into omega n. So these are the distinct roots for this d operator equation, which is called as the auxiliary equation. And therefore, the complementary function, so it is written as a constant a1 e raised to, so you can use the first root d1, which is the minus zeta plus square root zeta square minus 1 into omega n into t plus the constant a2 e raised to second root d2, so which is a minus zeta minus square root zeta square minus 1 into omega n t. Okay, so actually it has this format: a1 e raised to d1t plus a2 e raised to d2t. So we have already seen this, how to get this complementary function by using this d operator equation. Okay, so you can refer that derivation in the module 4 in the damp vibration. So this is the complementary function equation. Okay, so depending on the zeta value, we will have the different waveform for this equation only. So actually this is a half part of the complete solution. So our complete solution is x for the force vibration, which is a complementary function, and the particular integral. So now we should find out the particular integral. Okay, so for the particular integral, we have to consider this complete equation. Okay, so by taking this complete equation, just write the equation for x. So x is equal to, so take this left hand side on the right side, so which is 1 upon d square plus c upon m into d plus k upon m into f0 upon m sine omega t. Okay, now this term, which is a f0 upon m, it is a constant value. So this is f0 upon m Okay, so now to solve this equation, so we should use the rule of D operator method for the trigonometric functions. So if you have the equation, so this is a quadratic D operator equation, which is a D square plus some constant value B. I will use small b into D plus constant B2 into sine AT. Okay. So if this is the equation, then we can write its solution. Just replace this D square by the minus A square. Okay. So it is minus A square plus B1D plus B2. Okay. Just we can replace the D square term, not the D term. So use this rule for this equation, which is a x particular integral. So therefore, we can write x particular integral. This is equal to f0 upon m, which is a 1 upon minus omega square plus c upon m d plus k upon m into sine omega t. Okay, this sine omega t term, it will remain as it is. So after that, our final aim will be, we should cancel all the d operator from the denominator. Okay. So just rearrange this equation